Welcome to the first of a three-part series to Understanding Your Digital Thread. Understanding digital threads is relatively straightforward, but implementing them and maximizing their value is more complex. But this is not changing organizational expectations on data transparency and availability. Access to data when it is needed and without questions or issues. And while security, access, speed, and trust are all critical issues, these are expected to be managed. But an enterprise application landscape is complex. Multiple systems are created for different areas to support a digital thread, and they need to be integrated. These different applications create some common challenges, such as different data formats and canonicals between systems, as well as disconnected and disparate silos of information. An example is maintaining item codes between systems because of different field codes and formats. This comes to life if a company wants device ID data identification and sharing for shop floor to top floor visibility. Understanding scrap quantity with codes, defects with codes, downtime with reasons, and cell configurations across plants is typically difficult without this completed integration. Digital twins, smart manufacturing, and digital threads are different initiatives, but are intertwined and related to each other. Smart manufacturing initiatives require usage of most, if not all, of the applications shown here, as well as some not shown. And this initiative typically provides large returns, according to McKinsey. A digital thread refers to connected data in the flow of an asset, which can be a product, a part, or assembly, throughout its life cycle across traditionally siloed functional organizations. A digital thread also obtains and delivers information seamlessly to all applications. To connect data between disparate internal systems, a variety of methods and technologies are used, and they typically include IT/OT integration, microservices, as well as API and services-led integration. To integrate and connect product data out to suppliers, another part of its life cycle, requires another set of technologies. And some of those technologies overlap with the internal connectivity. APIs are used, as well as traditional B2B languages like XML and EDI. An important key to enablement is to ensure robust processes for fast vendor setup and maintenance, simple GUI interfaces, so IT is not wholly relied upon, as well as supplier self-service portals so that suppliers have the ability to create and maintain connections. One of the key outcomes for a digital thread is a combined IT/OT dashboard showing the metrics of improvement that is consistent and shared information throughout the entire organization. BI becomes an enabler for executive-level analytics and decision-making. And when these challenges aren't met, some symptoms include lost and reduplicated data that's entered into multiple different systems, paper versus digitized data on the shop floor, difficulty auditing the history of a product throughout the entire supply chain, high procurement and engineering costs from creating and sourcing duplicate products, higher than needed amounts of materials, WIP, and finished goods inventory, which looks normal, but it's not, but that's because the organization doesn't know any differently at this point. As the enterprise manages to create an organizational-wide digital thread, additional capabilities can be treated as data points that are both internal and external to the enterprise. Additionally, these capabilities span multiple functional areas from production to field services to engineering. As part of a digital thread, IoT-related capabilities such as smart tool usage and tracking and lone worker monitoring can be supplemental, as they both require and add data to the thread. The same moniker holds true for IoT-enabled connected products that can be used to support improved aftermarket services such as predictive maintenance or warranty assurance. The digital thread is a relatively new term, but the concept is not new, and the implications for obtaining a complete digital thread are significant.